good now.
Okay. Hi, Alex. We're gonna do a thing, okay?
Hello.
So if we're gonna find the limit of x squared minus 25 over x plus 5 as x approaches negative 5, we'd plug in negative 5, so we get 25 minus 25, 0 over 0. So that don't work. We don't like that. So before, what we would do is we'd factor. So we'd do x plus 5, x minus 5 over x plus 5, and those two would cancel, so it'd be x minus 5, so it'd be negative 10. But we can do it a different way with a guy called L'Hopital, because he's a cool cat. So what we do is we take the derivative. We do 2x, and then we do over 1. So then we do 2x, and then we plug in x, so it's negative 10. And it's golden. And that's called L'Hopital's.
Tell him not to do quotient rule.
Oh, right, you don't do quotient rule. You just do the derivative of this, derivative of this. These are separate, so you just carry it over. So you do 2x over 1. Now it's somebody else's turn.
All right, Vince. I'm going to say this one time and one time only. We've got x cubed minus 1 over 4x cubed minus x minus 3 as x approaches 1. I'm not even going to factor that because that would just suck a lot. Like, I'm not going to do it the old way because that'd be a huge amount of problem. But yeah, so we do plug in 1 for the x, and it's going to be 0 over 0. And you can only do this if it's 0 over 0, or infinity over infinity, or negative infinity over negative infinity, or like negative infinity over infinity.
When the answer is
Yeah.
indefinite, is that what she says?
Indefinite.
Indefinite, yeah.
No, it's something.
Something.
But when it's 0 over 0, basically. So with this, we can go 3x squared over 12x squared minus 1. Can we plug it in? Well, I think so. That just gives us 3 11ths because 3 is 1 squared over 12, 1 squared minus 1. That doesn't matter, that doesn't matter. 3 11ths. And that's what we would have got if we took a long time to do that. Marno, you're up.
Alright, I'm up. Alright, Vince. They stuck me with the tricky one because I'm the dumbest in here. No, I'm just kidding. So, now we can do the same thing when it involves trig theorems, right? So, if we do sine times 5x over 2x and it approaches 0, we put 0 at the bottom, 2 times 0 is 0, and then we put 0 at the top. So 5 times 0 is 0, so sine of 0 is 0. She reviewed the graphs with us. So like the sine graph, it starts here and goes up and does all that jazz. And then like the cosine graph, it starts up here and then it goes down and does all that jazz. So that's how I do it now. It's like the sine is 0, I just think of the sine graph, and at 0, sine equals 0. So do it like that. So now, get all this junk out of the way.
Just a little bit louder.
So now it's 0 over 0, right? So now we take the derivative of the top times the derivative of the bottom. So the derivative of the top is cosine 5x, and then you remember it's, what is it, chain rule?
Yeah.
Yeah, chain rule, so you gotta put a 5 out here too. Right? All over 2. Right? So now you can plug in 0 for x. So cosine of 0 is 1.
We're teaching Alex how to math.
And then times 5 all over 2, and so that just brings you out to 5 over 2. Repeat. If you didn't understand it, just rewind.
A 1 and a 12, or a 2 and a 12.